Hello everyone, and welcome back to another video. This is part 2 of the GTX 960 Windforce repair series, and this will be the last part, because the card works. So, I'm filming this at the end of a several hour long testing and then benchmarking session, where I finally figured out how to make this card work, and you can already kind of see how I did that. So I'm gonna take the heatsink off, and while I do that I'm gonna talk a bit about the history of the card so you don't absolutely have to rewatch the first part of this. Basically, the story of the card is it came in with immense physical damage, something that I wasn't actually aware of because the listing only showed the front, and I only went for it because the card was only 15 euros, and for that price you might as well take the risk for the card being in a rather unfortunate state, which it was. And basically what happened was that there were two areas where the physical damage was most concentrated in. You can see around the core there's several mangled capacitors and just a ton of missing capacitors. This is the first place where the damage was concentrated, and this damage has not been fixed yet. The card actually works without this, which is something that I predicted, because there's this one resistor which was spared. As you can see, everything around it wasn't, and everything around it was just capacitors. Now, I did acquire a board view for this card. I can't tell you how I got that board view, but I can tell you that I have a board view, and I was able to check that basically all the capacitors missing around this area are VCore or VMEM filtering capacitors, which the card can work without. Filtering capacitors, especially output filtering capacitors, are usually redundant, and in this case they absolutely were. And then the second area with concentrated physical damage was this area. And this area houses the two BIOS chips. And yeah, so both of these BIOS chips were missing, and this little 6-pin switch next to them was, and still is, also missing. So, the card didn't have any of the two BIOS chips, which of course means that the card doesn't work because it doesn't have a BIOS. And however, even without a BIOS chip on the card was actually still detected as a GTX 960 in Windows. You just couldn't really do anything with it. You couldn't install the driver, you couldn't really read a lot of things from it because there was no BIOS on it. But the GPU chip, the GM206 here, was still recognized by Windows as what it was. So the idea was, just put on a new BIOS chip, and then flash a working 960 BIOS on it. And that's basically what I did. The one problem is, it wasn't just missing one of the two BIOS chips, it was also missing this switch, which determines which BIOS chip is active. Now, this card is a bit weird that it has two BIOS chips that they can actually switch in between. There is no BIOS switch on this card anywhere that you can flip. My best guess is that the two BIOS chips are necessary because of Gigabyte's many output solution. Because this card has more outputs than basically any other 960 that you can buy. And as far as I know, the video BIOS for NVIDIA cards needs to has a register in it that determines which outputs the card has. And this card having more outputs than it can support at the same time probably has two BIOS chips, because you might be kind of able to see on the I/O shield here, it has this outline around these. You can choose between having this DVI port or these two display ports. So what probably happens is, when you plug in a cable into one of these, the card senses that using these two switch ICs right here, because I did check the board view and these two are connected to that 6-pin switch somehow. And the card probably can tell which ports are occupied and then switches to one of the two BIOS chips. One has the two display ports on it, the other one has the DVI on it. So that's probably how I think the dual BIOS works. Now, my fix only has one BIOS chip working. The second one on the left I could actually remove again. It's not used in this case, because this 6-pin switch that usually exists here cannot be replaced. Because as you can see, the pads for this thing are just absolutely destroyed. There is nothing that can be done. Like, I could try trace repair, but it's just way too fiddly for me. I have no tools that are small enough to do this. So I used this wire instead. So because I have access to a board view for this, I was able to trace out where the 6-pin switch goes. I also know which model of 6-pin switch goes here. And basically how this switch works is that it has 2 power pins, a ground and a VCC pin, which just power the switch, and it has 4 logic pins. 1 input, 2 outputs, and a control pin. And the control pin determines which of the 2 outputs gets connected to the input, which is used in such a way that one output is BIOS chip A, the other output is BIOS chip B. And that way you can choose which of the BIOS chips is active. Now what I've done is, instead of putting another switch on it, which I can't do because the pads are ruined, I traced out where the switch connection goes and just force-enabled the right BIOS chip by just soldering wherever the trace from the switch goes directly to where the output of the switch goes. So basically this wire is simulating what the switch would do if it is in the state of enabling the right BIOS chip. It's just soldering this wire. So yeah, it solders to one of these empty pads here, and then just to this leg on the BIOS chip. So if you have any, if you have this card with simulation, you can just do that fix. This same circuit is probably something like that implemented on all the other Gigabyte cards which have this many output solution. Because these 2 BIOS chips are from the GTX 980 Ti G1 Gaming, which also had 2 BIOS chips despite not having no BIOS switch, and also had a little 6-pin switch next to it. So that card probably also has a very similar circuit. Anyway, I put the BIOS chips on, I force-enabled this one, and at that point, I was able to flash a GTX 960 VBIOS onto the chip because, well, these chips came off a 980 Ti, and this 960, for a brief period, believed itself to be a 980 Ti, which is quite hilarious, but not what we want. So, in using the board ID mismatch disabled version of NVFlash, I was able to flash the 960 VBIOS onto this thing, and that made the card put out an image for the first time. However, that image was quite mangled. It had a lot of memory errors. I ran maths, and every single memory chip with every single bit was failing. And at that point I thought, oh no, there's something messed up behind the core, isn't it? As it turns out, there wasn't. There was instead something messed up in my head, because I flashed a 4GB 960 BIOS on this. And that right there very clearly states 2GB. So it took me a good 30 minutes to notice this difference. I then flashed a 2GB 960 BIOS onto this, and would you look at that, the card works. It has this super janky bodge wire repair. It is missing a good 30% of the capacitors behind the core, but the card works. And it even overclocks. I am genuinely surprised how good this card is. It does 1555 MHz core and 2153 MHz memory. Now this is on Samsung memory, which is known to be pretty good at overclocking, but that's like an 800 MHz offset on the memory. For a 900 series card, that's kind of good. And the core at 1555 is not bad either. Now it's not 1600, but like, considering the state of the card, I'll take that. Like, that's the same clock that the best air-cooled 960 on HW board has, so... And my memory is better than that card. I am getting a lower score though, probably because of clock stretching. But anyway, the card works. I now have a 960 with probably the worst implementation of dual BIOS ever. I can still use the other BIOS chip if I just resolder this wire to the other BIOS chip and then force enable that one. So it still kinda has dual BIOS, you just need a soldering iron to switch between them. I could actually just enable this with like an actual switch. Like I could just solder an actual switch there and then have selectable dual BIOS like that. Maybe I'll do that, that would be kinda cool as a feature. But yeah. The 960 is working. And all it really needed was 2 new BIOS chips, because the card didn't have any, and this one wire. That's all it did. I didn't have to do anything to the super messed up back of the core. Now I probably will try to solder more capacitors to this, because like when I try to do extreme overclocking, even if it already does well, it's gonna do better if I fix that. But yeah, I'm just happy that I have this thing working, because right now I kind of like the smaller tier cores. Like, you know, I've just made a series about this GTX 960 here, which you can see is prepared to go sub-zero now. And yeah, now I have a 960. I also have 2 760s. I don't have a 660, and I don't have a 2060. But I kind of like 60 class cards, because they're really fun, very moddable. You can get nice PCBs, like this is a really nice PCB. Very nice to overclock, very nice to mod, very fun, easy to cool. Whatever. So yeah. This is probably one of the coolest repairs. Like, it's super janky, but I'm just amazed that this thing works. Like, this is far from a sellable state, but it is a usable state. Like, if I was desperate for a graphics card, I would daily this. Like, there's no reason why this wouldn't work. It's not like this is any power delivery related stuff. It's just the BIOS chip either works or it doesn't, and it does work. Yeah. And I think I'm just rambling at this point. So, yeah. Thank you all for watching. I hope you enjoyed. I hope you learned something. I certainly learned something today, which is how Gigabyte's weird dual BIOS probably works, and what happens if you flashed the wrong VRAM size BIOS on your card. And yeah, that would be it. Until next time. Goodbye.